We'll just wait a few minutes. There's people entering now. I can see the number of participants going up. Well, we might make a start. Hi, everyone. Thanks very much for joining us and a very warm welcome to you all. My name's Dr. Matthew Harrison and I'm an Associate Professor at the Tasmanian Institute of Agriculture in Launceston. And today we have a fantastic line of speakers here to talk to you from the Tasmanian Institute of Agriculture and from TasAgco about using biochar as a feed supplement. So I'll see if I can share my screen. Hopefully you start to see something on your screen in a minute. Before we begin, I'd like to acknowledge the traditional owners and custodians of the land upon which we meet today and recognise their continuing connection to land, waters and culture. We pay our respects to their elders past and present. I'd also like to acknowledge funding for this research, which was provided by Meat and Livestock Australia and the Tasmanian Institute of Agriculture. Just a little bit of housekeeping. The webinar is being recorded and the recording will be distributed after the webinar. Please ensure that your microphones and cameras are turned off throughout the course of the webinar until the end, and at which point you'll be able to turn them on. Questions to the speakers are encouraged throughout the course of the webinar, so please use the Q&A box down the bottom. You should see a number of icons down the bottom of your screen. If you hover your mouse above those, you'll see a Q&A box. We'll try to answer those throughout the course of the webinar. If not, we'll answer them at the end. Now, it wouldn't be a proper webinar unless we have technical issues. I'm not expecting it to be disconnected, but if it is, just rejoin with the original link. Why would you feed biochar, essentially a pyrolyzed wood product, to livestock? Well, there's multiple anecdotal benefits associated with feeding biochar to livestock. One of them is that it improves the surface area of the rumen and therefore the area for energy exchange and potentially live weight gain and therefore productivity. Another one is that it enriches the organic carbon content of the manure and therefore animals essentially soil carbon spreaders or spread out carbon across the paddock depending on your stocking rate. There's a farmer in WA who has fed biochar to his cattle for a long time, and he says that the biochar enriches the manure, and you can actually see the dung beetles carry the manure down into the soil, and you can see the black tunnels from the biochar carried into the soil, and it enhances soil ecology and biodiversity. It's also said to reduce enteric methane, enteric methane being the methane that's produced in the stomach of the animal by fermentation. Can also reduce when applied to the soil methane, and actually soils produce methane particularly when they're waterlogged. Can reduce nitrous oxide from the soil, methane and nitrous oxide being really potent greenhouse gas emissions. And if it actually does improve live weight gain, well, you would think that it would have a productivity benefit and therefore a profitability benefit depending on the cost of the biochar. So the purpose of our work, and really what we're about to touch the tip of the iceberg about here today, was to trial a commercial feed grade biochar on a commercial farm as a livestock supplement. And we'll have Sam talk a little bit about that shortly. We really wanted to contextualize the results, so dealing with the real practicalities of feeding biochar as a feed supplement in commercial settings. And as I say, Sam should be able to elaborate a bit about on that shortly. What's it like to move the troughs from paddock to paddock, and what did he learn from it? We looked at biophysical indicators, so botanical composition, pasture biomass, live weight gain, worm burden. We looked at organic carbon content of the manure. The second part of the experiment was really a social aspect, so we really wanted to gauge farmer and industry perceptions of those who turned up on the farm workshops, to hear not just from Sam, but on other workshops as well. Because we're limited with all field experiments to a finite duration, 2 or 3 years, we thought to fast track that, so we went to other farmers as well, 2 farmers in Tasmania, one who have fed biochar for 5 or 10 years, and we actually had on-farm workshops at their farms. One was in the northeast, another one was in the far northwest of Tasmania, to hear from those farmers as well on their perceptions of feeding biochar to their animals, not just biophysical but also environmental. And the last part of the webinar will briefly touch on the cost benefit mitigation scenario analysis. So with a field experiment, you're usually dealing with a finite set of results. So you get one sort of live weight gain, you have one impact on enteric methane or not. What would have happened if that had a varied? So if you had a different impact on enteric methane or a different live weight gain, or the biochar was a different cost. So that's the point of a scenario analysis. As I say, we're only dealing with the tip of the iceberg here in this webinar today. People who are interested and want more details, it's online, it's in that publication. You could take a photo of it, or feel free to send me an email and I'll send you a copy. We do have one brief poll. I'll just see if I can stop sharing my screen. And the purpose of the poll is really for you, to help you understand who else is here today. I'll see if I can relaunch this poll. Hopefully, you should be able to start to see a poll appear in front of you now. Can people see that now? Yep. So there's 6 brief questions there, and hopefully people who are on the line can actually see that. You should just be able to click on it. So the first question there, and I'm not sure whether attendees can actually see it, but the first question is, I attended this webinar, and you should just be able to click on those options there and sort of let us know what you find. So I can see that one answer has been entered, which is good. So people can actually enter that. So I'll just wait a minute or two for people to enter their responses there. This is a little bit authoritarian because I can see how many people of the total attendees have entered their answers. So the first question there, I attended this webinar because I'm interested in biochar as a feed supplement. I know some of the presenters. I trade carbon. I was bored. I had nothing else to do. The second question, assuming you're not a computer algorithm, you're physically located. Where are you located? You're sitting in Tasmania, Western Australia, Northern Territory. You're not in Australia. For farmers, your current occupation is, well, for everyone, your current occupation is farmer, research, student. The fourth one there, and the fourth one's only for farmers. If you're a farmer, what size is your property? The fifth one again is for farmers. What do you farm? Is it cattle or dairy or cropping? And the sixth one, which is the final one, is your main interest relating to biochar, and it's really quite extensive, as we've done with the study. So I'd be interested to hear what people's main interest is, and when everyone's had a chance to enter their responses. We've got 106 out of 152, so a few more to go. I'll share those results, and it's actually quite interesting what people are saying. So we'll just wait another 30 seconds. We have 120 out of 153. And we might just about wrap it up there. And I'll see if I can share these results. Hopefully can people see that on their screen now, the results? Yep. I'll briefly go over those just quickly. Most people here, 74% of people, are interested in biochar as a feed supplement, and most of the others, about 34% are carbon farmers. Some of the people trade carbon. Physical location, wow, we've got a pretty even spread. Tasmania, Victoria, New South Wales, WA, 12% not in Australia, that's good attendees. Current occupation, again, pretty even spread. Farming, industry reps, government, okay, yep. In terms of farming size, 12% less than 100 hectares, 10% between 150 and 500 hectares, a few between 500 and 1,000, one between 2,000 and 5,000. What do you farm? Well, pretty even spread again, beef, cattle, sheep, dairy, cropping. And the sixth question there, your main interest relates to the effect of biochar on soil carbon, soil health, animal health, live weight gain, profit and costs, regen ag, lots of things. So that's a good even distribution. So I'll stop sharing there. I'll now see if I can share my screen again. Hopefully that poll has disappeared from in front of you. Let me know if not, Karen or Nikki. So I'll hand over to entrepreneur and innovator and award-winning businessman Sam Trathui. Sam owns the farm in which we ran the commercial trial at Deloraine in northern Tasmania. So I'll hand over to you, Sam, and I'll go through a few slides while you're talking. Hopefully you can talk.
Yep, you got me, Matthew.
We've got you.
Excellent. Thanks, mate. That was a very generous introduction. Hi, everyone. And yeah, awesome to see the spread of people that have dialed in from around Australia, but across the world. I saw Francesco there from Bolivia. That's pretty cool. So yeah, really great to have everyone on board, and a big thanks to Matthew and the team for pulling this together. It was a really interesting trial, and it was one that we enjoyed. So basically, I'm located in central northern Tasmania. We've been here for about 4.5 years. We bought this farm, and yeah, we run a grass-fed Wagyu operation that we set up kind of from scratch with our own kind of sire genetics, and we use dairies to build up our herd, and now we kind of breed from our own heifers and cows. We aggressively pursued the, I suppose, a whole bunch of sustainability-based stuff. I had been exposed and involved with that kind of stuff for many, many years, both on and off farming. And I wanted to give it a go and whatnot. So yeah, I suppose, are we regenerative? Absolutely. And we have a whole bunch of different things that we have done in the past and continue to do that I would argue define us as regen. I suppose we don't probably do as much as we used to. I started out as a very high input regenerative farmer. And I've kind of taken the pedal off the metal, as I think I wasted a lot of time and money chasing things that I think were a bit of a waste. So you can see some photos there of our cattle. We really, the trial for us was pretty interesting. So I've never been involved in anything quite like this since school, because it quite literally was a proper trial. We had a control group, the biochar mob. We had tagged them appropriately, so if they ever got boxed up or they got moved around, we knew who was who, which happened very, very rarely. And we really ran them. We would argue, keeping in mind we're not a research farm, so we're not this kind of, and with all due respect to the researchers, but it's not like a fully controlled, sanitized kind of environment, and where nearly all things are somewhat equal. Like, we are a commercial farm, so fences break and shit happens and animals get boxed up, and you've got two different mobs running in two different parts of the farm, and some paddocks did have our multi-species in them, some didn't, but then we made sure that we swapped them around. And so we really did everything we could within the commercial confines of our rotation and our business to ensure that they were treated the same when they were fed out. We fed them the same hay, the same silage, they were the same number. So yeah, we did what we could. So we started out putting the biochar in troughs. I mean, biochar as a substance is pretty forgiving compared to other loose lick. Like, it's obviously just charcoal with a bit of the stuff we use. And I'm not a biochar expert by any stretch of the imagination, but it also has a little bit of bentonite mixed through it as well, like a tiny amount. So we started out chucking in the troughs, which was pretty easy, right? And we had them linked up, and then we just dragged them around with the quad bike when we moved the cattle. We actually found once it got wet that it kind of sets. and it really just, yeah, it kind of sets, I wouldn't say it's like concrete, but all of a sudden it's not as palatable or fun or accessible for the livestock. So we found by putting them in a covered feeder like this one, it was really good. And it also meant that we didn't have to, fill it up regularly. It was kind of like a, I think a bulker bag had fit in there from memory. And, you do that once every however often, which was quite a while. So that worked out quite well. I suppose as the cattle got bigger, that particular feeder posed a few issues around them actually physically getting their heads in, especially if they, for whatever reason, had horns, which a handful of ours do. So, there's always like logistical kind of, application issues. And so, yeah, they average 30 grams per head per day. I mean, again, like I said, we're a commercial farm. You could have gone and had walkover weighers or an opti weigh, and you could have had RFID tags tracking which ones did and didn't come. So who knows? We just know that that's what they did on average. There were no doubt animals that loved the stuff and other animals that hated it. What we did notice, which was a big aha moment for us, was that it is, really the most stable source of fiber you can get, right? Correct me if I'm wrong. So obviously in times of the year where we've got, like early spring where you've got, and early autumn when we get autumn meal thrift and things like that, where you've got, a lot of energy and protein in your plant, but you don't have the fiber in it. That was when they hit it. So we naturally found that their consumption went up and down as for when they needed it. If we start getting into myotox, I'm wandering out of my knowledge base here, and I want to be careful given the company that I'm on the call, but we start thinking about, toxicity in ryegrasses and we're ryegrass predominant here. And we also know that civilizations and animals have used charcoal as a detoxification tool for forever. How much of that had to do with toxicity in ryegrasses at any one point in time, I don't know, but there certainly was cycles where they would eat some and not touch it. And so in the middle of winter, when we're feeding out a fair bit of hay and silage, they really didn't touch it that much. So that was kind of really, really interesting. We also found that, we measured pasture biomass again, what they were going into, what they were coming out of. And we kind of did everything we could. We also had some shifts in our own strategy throughout this trial that made us it difficult to keep managing the trial as we had intended. And we did end up having to finish it a little bit early than what we would have liked, but I still argue that we had fed them for quite some time. If you were to compare us to a fattening operation where you're buying them as a weaner and taking them all the way through to kill weight or whatever you're doing. But it just got to a point with the two mobs of the same size on different rotations that we had to kind of make a bit of a commercial decision. But so we measured the pasture biomass with a plate meter, which was really interesting. We ran a field day with Matthew and the team, which was great. Always enjoy the great questions and challenges that come out of the audience on those days, and we walked through pastures and did a lot of that stuff. One thing that we did notice, and I know Matthew calls this anecdotal evidence, but any farmers on the call would appreciate we live and die by anecdotal evidence. We make $100,000 decisions on anecdotal evidence, unfortunately, on a regular basis. And so we noticed that the biochar mob, they threw their coats pretty early in the spring. The control kind of really hung on with their coats. As I said, anecdotal. In my mind, what does that mean? We're northwestern Tasmania is notoriously deficient in copper, cobalt, and selenium. We know that copper is a contributing factor to having clean coats. So by the fact they had a really stable source of fibre, was that slowing them down in that they were able to really get the most out of that feed and make the most of the trace elements and minerals that were in that feed, one of which being potentially copper and whatever else. And then they were ultimately perhaps a healthier animal there for a point in time or during the trial being on the biochar. I don't know. Again, these are all the little things that you notice as a farmer that are difficult to quantify, and that's obviously not what necessarily the study was about, but they're the little things that you notice when you're out in the field all the day that ag tech will never quite ever quantify, and it's difficult for research trials to do the same. So we did finish this trial in February, coming into another winter, starting to get our rotation organised. I wanted to make sure that we were going to have our best winter yet, because we've had a couple of shockers which have been due to management, and so we unfortunately had to end it. But we're killing some of those animals now. Obviously, given the genetic diversity in their dams with the way we run our business, and I won't bore you with details, and the fact that since the trial finished in February, as for their carcass performance, we own our own abattoir, so we process everything ourselves, and I can walk in and look at what I want when I want. And but yeah, I can't talk to any differences in carcass feedback or anything like that. But yeah, these animals have done quite well. And I suppose in some ways they were some of the best drop that we'd ever managed through. But again, using anecdotal evidence, we'd also gotten our management progressively better over time as well. So my wrap-up piece, because I'm mindful of time, is we generally found it pretty easy. Like, it's a very forgiving product. Fed it out in the feeders, didn't need to worry about it too much. You don't eat that stuff unless you really got a need to, right? So I suppose from a regenerative point of view, I do have a bunch of other questions and concerns for why we need to feed animals charcoal every single day, or why they want it every single day, rather, because I would argue that that's not something that in a natural environment they would do. They would definitely draw upon that every so often when they need it, but as for needing it every day, my intuition is that points to a problem that biochar is solving up in relation to a symptom. So, but as far as the trial went, we were quite happy with it, and yeah, I'll let Matthew do the rest.
Thank you very much, Sam. Very interesting. I see a few questions come in there in the Q&A. Feel free to have a go at those if you want, Sam, or we can answer them at the end. Hopefully people can hear me at the moment. I won't spend too long on this slide. Really, just to say that the botanical composition, that chart on the left, was not significantly different between the control and the biochar cohort. That's good, because if there was a difference, they could potentially, live weight gain could potentially be confounded by differences in pasture quality or type or what they eat. The chart on the right was really just amount of biomass, and the open and closed dots are really just the cohort and the control there. No significant difference between them. Typical of southern temperate systems, you see that ramp of growth rate in spring. We also looked at organic carbon in manure. No significant difference between them. In future, we could do more detailed sampling regime for that, but for the results that we saw, which were analysed in the lab, we didn't see a significant difference. Probably the crux of the physical experiments is that chart there on the right, animal live weight, and those numbers are very rigorous, very robust rather. There's about 140 animals behind each point there at the start, and then we ended with 60. We had to downsize sort of halfway through. What we did see, the black line relative to the open dots, is that the biochar cohort had a 5% gain, significant gain in live weight, and you can see a slight change in trajectory of the black line relative to the open one. So we think if continued for longer, there could have been a bigger live weight gain, but again, that's probably something that you could address in a future experiment. Other work has shown that different types of biochar might have a different effect on livestock. So this is not our work, this is just from a peer-reviewed publication. I'm not going to go into the details, but they fed these cattle 1% biochar of their diet for about 2 months, and they showed more than 20% live weight gain. That biochar was actually made of crop residue, so it was actually made of rice straw. So you get very different. There's possible there that you get differences in live weight due to the type of biochar, and that was because these animals, actually the ones consuming biochar, ate more. So that's why they actually put on more live weight. Now, other work, and this is not our work, other high-profile work has shown that biochar might also stabilize soil organic carbon. How does it actually do that? It actually slows down soil organic carbon mineralization, or the loss of soil organic carbon, by over 5%. It actually does that by accelerating the formation of microaggregates via mineral organic formation. So that's the mineral content of the clays or the other soil that it's associated with binds to the organic matter in the biochar and therefore physically protects it, so it can stabilize it. So what you can see big differences between sort of soil type and climate type and pasture type and the actual amount of biochar that the animals eat. So we think there's probably good scope there for additional research and to continue with different types of biochar and, you know, different agroecological locations to get a sort of a robust measure of what actually happens. I can see that Alec has got his hand up. We might just wait until the end, Alec, if you want to put your question in the Q&A. I'll stop sharing now and I'll hand over to my colleague, Dr. Nikki Barnes, who's at the Tasmanian Institute of Agriculture in Burnie, who led the social research and the on-farm workshops. So over to you, Nikki.
I'll just put this up. I hope I've managed to do that okay.
Yep, all good.
Beautiful. Okay, so the part of this, our trials that I was focusing on was more about how all this was going to happen. So if somebody handed you over a 1-ton bulk bag of biochar and you're well within your rights to think, well, what am I going to do with this? How is it going to work? So that's the focus for today. So while we were doing the trial, we had three sources of data. First one was 2 case studies that we did with large meat producers who were using biochar. The second one was surveys that were conducted across the 3 workshops that we did in Northern Tassie. We had about 72 people attend those workshops. We got 37 of them to give us feedback, and about 65% of them were intending to start using biochar. The third lot of data that we used were from interviews. So in 8 to 12 months after the workshops, we then went back and phoned some of our people who had attended, and we got what they had been doing over that last 8 to 12 months. 7 of them had already been using biochar prior to the workshops. 5 of them had started using it after the workshops. 5 hadn't started, but were still considering how they might get into it. And 6 of them had actually started to make their own biochar and were using it on farm. So the focus on what I'm presenting here today is just on those 12 people who we interviewed, who were talking to us about biochar and how they were using it on farm. So for most of our farmers, our trial was about live weight gain, but that wasn't what they were interested in. They had 3 goals predominantly. Animal health was their big one. A combination of animal and soil health was the second one. And the other one was holistic management systems. And we've termed that around things like regen farming, organic farming, and other types of systems that look at the whole farm rather than just a point of contact where you might use biochar. Now, throughout this little presentation, you'll notice that I've got some italicized things here. Those are quotes from our farmers. Just see if I can move these out of the road. So one of the things that farmers were telling us were things like a whole system process, not just the animals, but it's also the soil that it's helping to balance out. Another thing that producers was telling us was that they wanted more research, and I will come back to this statement a little bit later on. And what they're saying is that the science isn't there yet to back up the claim, and it's going to be very tough to promote a product when the science is not in on it yet. The farmers that we talked to told us numerous amounts of benefits that they were seeing. And like Sam, these are anecdotal things. And Sam, you'll notice some of these things are things that you noticed on your farm as well. So they were looking at decreasing toxins and pathogens in their animals. They were working to eliminate the need for fertilizers, and some of them had spoken about the reduction of fertilizer that they'd been able to use on farm. They were seeing improvements in gut health and consequent methane reductions. For sheep farmers, they were using it with fly strike and found a reduction in the maggots in the soil as well as their incidence of fly strike. Acted as a soil sweetener, and so there was an increase in things like dung beetles and worms following the use. People were using it for the treatment of mastitis. It complemented the holistic management practices. They weren't expecting biochar to be just a one-off hit, that silver bullet approach. So they were using it in conjunction with a whole heap of other things. Reduction in ringworm lesions, the reduction in dark cutters, which is good because that also helps with profit making on the other side of things. The shiny coats that Sam mentioned, also a change in consistency of manure or scours. And what that meant for sheep farmers in particular is that they had to do less crutching, but it also was an indication of cattle health. Some of the issues, there were 4 major issues that they came up with. Most of the issues were able to be overcome on farm, but some of these may also be something that the biochar industry can get their teeth into. So the first one was the form that the biochar was sold in, and although some people said that biochar as a powder wasn't a big problem, some of them said it was. So it sounds very good in theory, but it just didn't work. I didn't think it was practical. I think if we could get it into the grain or something like that, it would be wonderful. The second one was the cost benefits. Some of the farmers were saying things like, I think the biggest problem that we all seem to be up against is getting the cost down. It's just too expensive to use in bulk, which is what we need for the farming industry. Or the second comment there, it's fair enough for the veggie garden, stuff like that. Can it be good for a bigger enterprise? I'm not so sure. Along with those costs came specific equipment. So it wasn't just buying the biochar, you needed to have equipment. So we did trial it with the open troughs. Some of the other farmers were saying things, like it's really hard to lose the biochar when it's in the trough. The cattle will get into it. And of course, the other one that Sam mentioned was that it's not waterproof, so it tends to sit. When you go into the feeders, which we also trialled, they become more expensive. So in comparison, troughs, a couple of $100. The feeders were closer to $5,000. But what that did do means the whole bulker bag of biochar could be loaded into the feeder, and it was far easier for moving it around the farm. Feeding issues were raised, so people weren't able to know what the dosage was being given, and that was interesting for us as a trial. It had to be mixed often with other additives, so things like salt, molasses, grain, silage, all were used to be able to encourage feeding. The cattle weren't necessarily just going and trying it out for themselves. And there was an issue too if grain was used. So in Tassie, we have a never ever program, which means that cattle can't be fed grain to be able to go into that program in the abattoirs. So that's fine for sheep, but when it's being used for cattle and it's destined for the never ever program, that was an issue. The time it takes to use was a little bit of a deal for farmers. So in feeding out, and this bottom quote here, anything that you want a farmer to adopt, you have to take a job away. As soon as you start adding jobs, it becomes very difficult and hard to justify because we're busy enough as it is. So unless it's making you, serious weight gain, then it's for this farmer, it wasn't much point. The last one was some concerns over long-term impacts. Biochar, when it's done via fast pyrolysis, can produce what's called polycyclic hydrocarbons, which are carcinogenic. So that can be an issue. In Tassie, some of the biochar industry people have been working on things like the industry standards to try and overcome that sort of thing. So labelling on bags of biochar would say whether it was made via fast pyrolysis or slow pyrolysis, which can help overcome those sorts of issues. The second issue is that it traps heavy metals, which is great if you want to decontaminate soil, but if you want to put it into a feed, you need to be really careful about the feed not being contaminated. So that can be an issue. And again, industry standards are being developed so that can't happen. Other interesting things that come out of the literature is that while biochar is a carbon sink, it's also an oxygen sink, and we don't want to be depleting oxygen out of the air. So that's something that research has been working on. And the other one is around food security. Biochar at the moment is providing quite significant income as a crop. And so in the US, a lot of farmers have been converting their food crops to biochar crops. And so there was a scare there for a while that food security could become an issue. whole heap of delivery mechanisms. So these are the types of things that farmers were coming up with, these innovations to be able to feed out biochar. So the mobile feeder tended to be the best option. However, there were others. The 1,000-litre water bins with one side cut out and the bin faced towards the prevailing wind and rain tended to work. People were putting it into feedstock, so they'd mix it in with pellets or grains that they got from our feed companies that were down here. They would mix it with silage, grain, salt, molasses. We talked about that. One farmer had bought himself a pelletizer to try and pelletize the biochar so that he could feed it out more easily. Another farmer had mixed it into a drench of apple cider vinegar and yogurt. They had to get a special drench gun, but they had then drenched their sheep using the biochar so that they had exact measures of how much each sheep was getting. And of course, lick blocks was a suggestion as well, in combination with other minerals that stock might need. Some people working on a circular economy on their farm, so making their own biochar, buying their own kilns and then using farm waste to be able to produce their biochar. Local groups were looking at sharing a kiln and then hiring it out. And another farmer, we have an issue with gorse in Tasmania, so gorse was being cut down and used to produce biochar as well, and work with that circular economy. Sam mentioned this one. It tends to be a seasonal understanding of use of biochar by the animals. So one of the farmers was saying sometimes they eat a lot, other times they don't touch it at all. So knowing the dosage actually wasn't a big issue for a lot of our farmers, because what they were saying was that cattle regulates their own dosage. So those big times that Sam mentioned were early spring and coming into autumn, when there's a lot of it, it's soft and it's green. And so at those points of time, what we're suggesting is that the cattle would then self-medicate to help with those points of time. And that's probably that time that we need to have a look at in research to see why and how that's happening, and then be able to work around that to be able to manage when and how biochar can be used. Last couple of slides. So one of the things that farmers were saying was that we needed more research. Actually, the research out there is enormous. If you have a look at Google, 21 million hits if you just put biochar into a search. There's also, if you go into Google Scholar, which is our academic site, 420,000 hits there. So there is a massive amount of research that's out there. What we think is probably, the farmers are probably saying, is that this isn't accessible or acceptable forms for them to be able to use. And what they're actually wanting is exposure to people using biochar, that they can see these tangible, personally observed evidence of the impacts of it, and allaying fears that there's no evidence or these notions of hippie type solutions being used on their farm. And what they also are telling us was that as workshops were really helpful for them to be able to come to grips with how to use biochar. They're also, the other thing and the last thing that I'll mention is this waste versus incidental benefits. So when farmers were using biochar, if they were purely using it for animal health, producers saw a lot of waste happening. So like this comment down here, if I knock over the feeder and have to pick it up, or, I could lose a litre of day by the cattle knocking it over and stuff like that. So they were concerned if it was just for animal health that there were quite significant losses. However, if they were using it for animal and soil health or holistic farming management, then they could see the incidental benefits and the cost recovery that was coming. So incidental benefits might be, and the cattle were either consuming it or it was sort of hitting the ground. So either it was fine, there was going to be a benefit. In terms of cost recovery, one of the farmers said, there's no data set that I can go, yep, that data tells me that biochar works, Anecdotally now, the kill cattle and their dark cutting percentages were pretty good through those winter months, and it was the winter months where they were feeding out biochar with their silage, so that they were seeing this cost recovery coming back from however it got into the animals. And Matt, I will finish off there. Stop sharing my machine. Hand over to Karen.
Thank you very much, Nikki. Hand over to Dr. Karen Christie. She's also at the Tasmanian Institute of Agriculture in Burnie. Over to you, Karen.
Hi, everyone. So, yeah, as Matt said, because our trial had a ran for about a 12-month period and we had one set of animals, what we wanted to do is look at a cost-benefit analysis. And that'll become a little bit more explanatory in the next slide. And so what I did, I actually modeled, so this was a modeling experiment. It wasn't a field experiment, but took feeding of biochar to steers from around weaning age through to 600 kilograms of live weight at around that 25 month of age, consuming over that duration of around 40 to 45 grams of dry matter of biochar per day. So a little bit more than what Sam was seeing, but we've taken them through to a 600 kilo kill weight. And created a typical growth curve, and from that we're able to estimate enteric methane emissions. So this study, we just really focused on enteric methane and any reduction in enteric methane and change in soil carbon. We didn't look at other aspects like, as Matt talked about, methane in soils or nitrous oxide in soils. And then I sort of reviewed a whole range of literature to determine that there's quite a range of information out there about live weight gains. There's so we looked at a 0 through to a 15% improvement in live weight gain, and any improvement in live weight gain compared to like a control, we valued that extra meat at $2.75 per kilogram of live weight, which at the time we did this study was sort of, we've seen meat prices a lot higher, but they've pulled back in the last sort of period. And so we went sort of at a lower price for your meat. If you were achieving greater prices than that, then the profits would be further enhanced. Looked at 4 levels of methane reduction, had a control of 0 at 5, 10 and 15%. So we're saying compared to a control animal, this animal was fed biochar to reduce methane by any of those levels. We also wanted to put a price on that change in enteric methane. So we used 3 different ACCU prices or carbon prices, $25, $75 and $125 per tonne of CO2, either abated in terms of the reduction of enteric methane or sequestered by having that delivery of carbon through the animal, through the manure and into the soil. And we estimated that that biochar would have a carbon content of 65%. Again, there's a huge range out there. We could have looked at a whole lot of different sort of levels of carbon in that biochar as well, but we wanted to really look at live weight gain and enteric methane and those sort of 3 carbon prices. We also looked at a range of costs of biochar, because biochar, there's a range of costs associated with whatever the feedstock is going in and that process. So we looked at 4 different prices. So as you can see, we're building up different combinations here, anywhere from $500 to up to $2,000 dollars per tonne of dry matter. And what's important, we did this on a dry matter basis, but biochar prices are typically a dollar amount per litre. Importantly, we also did not consider any of those other co-benefits of feeding biochar that my colleagues have mentioned previously, like worm burdens or reducing dark cutters of the meat. We just focused on enteric methane, live weight gain, and building soil carbon. And I'll go through, there's a series of graphs that I'm going to go through. So I'll just explain. These are called surface graphs or XYZ graphs. And for some people, they may not have ever come across these. So what we have, it's a 3-dimensional graph, but we try to present it in a 2-dimensional way on our screens. So on the x-axis, we have that live weight gain from 0 through to 15%. On the y-axis, we have that reduction in enteric methane, again from 0 through to 15%. And then on the z-axis, which is the result, so it's the combination of those two gives us our result, which is the RNP is our profit in terms of dollars per head So if you're already making $200 per head on your steers, and then feeding biochar increased that profit by $100, your new profit would be $300. But this result, we're just looking at that net increase in profit. And as I said, we got these combinations. So this first dot, we're saying the profit of feeding biochar, if you got no live weight gain change, you've got no reduction in enteric methane, it's down in that really dark blue corner. So you're probably losing money because you're not going to profit for either live weight gain or reduction in methane. And so the product's going to cost you more than you're making in those two changes. But as you move from increase to 5% change in both of those, you start to see the profits increasing up into this sort of green area, which is getting up to that $100 to $150 per head by feeding biochar, if you were able to get that 15% reduction in methane combined with a 15% increase in live weight gain. What you can see, there's a lot greater increase in profit if you can improve live weight gain. You go from that dark blue, which is a low profit or even a loss of income, up to into that lighter green area. In contrast, a reduction in enteric methane doesn't give you that scope to make as much profit. So what I have here briefly, I have two different biochar costs. The first on the left is costing $1,500 per tonne, and the one on the right, $2,000 per tonne. And if we were paid $25 for any abatement or sequestration of carbon in the soils, and you can see there's not a great deal of difference on those profit profiles. They're sort of both in the green in that sort of 10 to 15% increase in live weight gain, and still quite dark down the bottom. But if we got to a place where farmers were paid $25 per tonne of CO2 equivalent abatement, you can start to see the lower the price of the biochar, the more profit you're going to make. It's sort of straight, simple economics. If you're getting more for your product, but it's costing you less to get that more product, you're going to be making more profit. So this was looking at profits per steer in that study. Then we flipped it on its head and we said, well, what's the break-even price for biochar? How much does the biochar need to be to actually be profitable? And here we can see if we made no change, if we achieved no change in live weight gain or enteric methane emissions, and the carbon price was at $25 per tonne, the break-even price for the biochar would need to cost less than $58 per tonne dry matter to be profitable. So if it cost $40, it would be profitable. If it cost $60, it would be unprofitable if you had no change in live weight gain or methane reduction. But if we were able to achieve a 10% increase in live weight gain, but still no change in enteric methane, the biochar could cost anywhere up to $4,100 a tonne of dry matter to remain profitable. So most of that change is because of that extra live weight gain. You could afford to pay more for your biochar because you're achieving much more profit from your live weight gain. But if we achieved a 10% improvement in live weight gain and we qualified for a 5% reduction in enteric methane, you're getting slightly higher. The biochar could cost slightly more to remain profitable. There's also a linkage between, well, what are you getting paid for that reduction in methane or sequestration? So if the value of an ACCU increased from $25 to $75 per tonne of CO2 equivalent for that same combination of a 10% improvement in live weight gain and only a 5% reduction in enteric methane, it goes from about $42.60 up to almost $4,700. So biochar could start to cost anywhere up to that price and still be profitable. You're still getting a better return by feeding biochar if the cost of that biochar is less than that those costs circled there. And I think that's the last of my slide, Matt, so I'll stop sharing. And hand it back.
Thanks very much, Karen. It was a good presentation. I'll see if I can share the second poll, and this is a very brief one. There's only 4 brief questions there. The information content is finished, so it would be good to hear what people liked and what they didn't like. Hopefully you can see that second poll on your screen now. Can people see that? Karen is nodding, so I'm assuming yes. Same format as the first one. If you just click on the responses, and we will discuss those once people have had a chance to enter their responses. During the webinar, I learned a few things, nothing. I was bored. The second question, information I saw today will make me use biochar, consider use biochar, make me think about using biochar in future, not change. Third question there, the most interesting parts of the webinar were the farm results, farmer feedback, cost of benefit analysis, Q&A discussion, which we haven't had a chance to do yet. The fourth question, you really need more information on what? So this is particularly important, that last question. What would you really like more info on? Soil carbon, soil health, profitability, environmental impacts, animal health, regen ag. Sam, there is a question there for you in the at the top of the open questions and answers. Oh, you've already done it, I think. It was for you, but we can see what questions. There's a good amount of questions coming in the Q&A there. We've tried to address some of those, but we'll keep going at the end. We've got 94 responses. Just waiting for a few more people to enter those responses. If people can do that poll, I'll just quickly share that poll. So I've got about 100 of 140 people. Just wait for a few more responses, and then we will have a concluding slide and open the floor to the Q&A. So hopefully people can see that in front of them now. During this webinar, 17% of people learn a great deal. Some people, 40% of people learned quite a bit. 40% of people learned a few things. The information you saw today will 10% of people thinking about using biochar, 22% of people considering using biochar in future, 67% of people thinking about doing more research on biochar, which is interesting, 20% no change. The most interesting parts of the webinar, which is quite interesting, the on-farm results, about 55% of people, Sam, good result. Farmer feedback, 56%, good result, Nikki. Karen, 60% for the cost of benefit analysis, so again, quite good. And the final question there, which is quite interesting really, we got an even spread. People really need more information on 48% soil carbon, 35% soil health, 55% profit and costs, 60% productivity, 46% animal health, 20% regen ag, so, and 40% carbon emissions and trading. So a good spread there. So I'm going to stop sharing that. And hopefully, has that disappeared from in front of you now, Karen, or not?
Yep.
Yep. Get rid of that. I've got one more slide to share, which is the conclusions. And then we will open it up to Q&A. So just to sum up what we heard, hopefully you can see the right screen. We used a feed grade biochar. It increased live weight gain by 5%. Didn't really have any impact on manure organic carbon, although we might have had more impacts had we continued for longer. There are plausible impacts of biochar on animal health, on toxin absorption, that sort of thing, but really need further investigation. Cattle tend to prefer drier biochar, so we converted to that covered feeding system in the wintertime, get a lot of rain in Tasmania in wintertime. The farmer feedback suggested that any intervention that minimises time and improves time efficiency would be a priority, and really feed supplement, relatively small time requirement, but we did hear about some of the limitations there. Live weight gains or carbon prices would need to be higher to be economical, but again, Karen showed a range of prices and costs there and carbon prices, so there is a big range to the solution space. We didn't really show it, but rates of adoption, we modelled long-term rates of adoption, which are relatively fast compared with other interventions. It took about 6 or 7 years to hit peak adoption, and the rate and the extent of adoption depends on perceived environmental benefit. And really, overall, there's probably a lot more scope for further research. And there's been some really good comments in the Q&A on existing resources, on links, on that sort of thing. We've found out that Bolivia is the biggest producer in the world, apparently. So there's a lot of scope there. There was a good comment about biochar reducing enteric methane. So there's probably good scope for further research. I'm going to stop sharing my screen now. Now, Alec McKay has patiently been waiting with his hand up the whole time. So if I hit that button, it could go spectacularly wrong. Or Brandon, we might need your help to... Alec McKay, I'll just see if I can let Alec to talk. So hopefully, Alec, you can talk now if you want to unmute.
Sorry, Matthew, I didn't realise I'd put my hand up.
Okay, if you haven't got a question, you had a good comment in the Q&A about cattle self-medicating on hay and also doing the same thing on biochar. Did you want to elaborate on that, Alec, at all? Or?
Yeah, just the comment that often if you got cattle or livestock on green feed, particularly in wintertime, if you put hay in the paddock, they'll go and eat 10-15% of their diet. They'll go and actually sort of medicate on a bit of hay. Presumably that's chasing some fibre, I presume. So that was kind of an interesting comparison. I suppose one of the outstanding question was roughly how much carbon do you think was being put back per hectare through the animal and dung, and is that biochar having any influence on urine N concentrations?
Good question, Alec. And again, you're much more of an expert in that endeavour than I am as an animal scientist. There are people who have done a lot of work on that, and they are on the line about sort of, it depends on stocking rate, it depends on how much they eat, so manure going back onto the paddock per se. So I don't have an answer with suitably low uncertainty to give you there, Alec. You could probably speculate better than I could.
Sorry, I was sort of calculating that each animal maybe was eating if they were eating 18 kgs per animal. I don't know what the stocking rate is, but is that sort of 60 to 80 or 60 to 100 kilograms of biochar going back per hectare in dung? I don't know, is that sort of in the ballpark? It'd be interesting, Sam's comment on this sort of guesstimate of how much was going back, or how much you fed in total, and do the sums.
Yeah, I mean, I'm just a farmer, and you guys from a science point of view. I would have thought if you've got 20 grams, I mean, when you buy biochar, it's sold by the litre, right? Volume based. So I would have thought 100% of what goes in should come out. Like can't imagine it's broken down and it's absorbed into their body. In my mind, it's used as a source of fibre. That's my total ignorant assumption. That's as much as I can kind of comment. So I'd assume everything goes in, comes out, and gets deposited around the paddock and works its way in over time.
Except for that proportion that gets integrated into their meat and the growth sort of thing. But other than that,
the biochar actually integrate, or
the biochar per se, yeah, I would assume most of it goes through the animal.
Yeah.
Alec, did you have any other comments on that? We're sorry we're a little bit vague on that one. That was take that on notice.
No, that's very stimulating. Really enjoyed the presentation. I suppose if you're trying to measure a change in soil carbon, you're probably still talking about quite small amounts with the noise behind it. So maybe don't do yourself too hard that if you're trying to actually pick up how that's impacting on the soil, just how many samples might you need to be able to pick up what's a relatively small difference against a very large background of soil carbon stocks.
Yeah, that's a good point. And that's probably an opportunity for a replicated experiment, with 3 replicates of each one and a dedicated soil carbon sampling regime. We didn't see any significant impacts on manure total carbon. So by extension, you might think that might not have had an effect on soil carbon, but again, we could have sampled more manure as well. So, but again, the on-farm stuff was only part of what we did. We had Nickies and Karens, and we had the other stuff as well. So it was, yeah, so it was a very multidisciplinary experiment. I might move on to Melissa. Melissa's patiently been waiting with a hand up there. So thanks very much, Alec. I'll see if I can allow Melissa to talk. You should be able to unmute now, Melissa.
Yes, hi, Matthew.
How are you going?
Great presentations. Nice to see you all. So look, just a couple of comments, really. It's really fantastic that you've put this on. I sit on the Australian New Zealand Biochar Industry Group, and I've also been doing biochar research for 10 years. So a bit of experience, and produced a dairy paper and then repeated the work as well. So just a couple of things that I just wanted to bring up. Firstly, the types of biochar are many and varied, and it's very important to think about making fit for purpose biochars specifically for animal feed, and they can be enhanced with lots of different things. And I think as we scale up the industry, the problem today is how the biochar comes. So it can come anywhere from powdered to how that feedstock was processed into biochar. So it might still be in the shape of a log, for example, and then crushed and so that's really, really important. And I think it's important for nutritionists to understand biochar and how it works. And each and every biochar should be tested. And those biochars that are working really, really well have been made as a fit for purpose char for animal feed. And so they can vary in terms of their benefits. We fed my first trial, I fed at 150 grams per head per day. I asked the farmer to feed at 300 grams, still had at least a half a litre per head per day in milk improvement for a year. And the second trial, we used 80 grams and had the same results. Okay. Generally less than 0.05% of an intake in rumen. The other things I wanted to comment on was the soil carbon. So after my dairy trials, I went on and did a replicated trial with putting biochar in dung and under dung. And we found great replicated statistically significant results for increase in soil carbon. We found mycorrhizae fungi increases, cation exchange, and soil pH increases. And so that can be found on those results on Carbon Drawdown Project's website. There's 14,000. There's a meta-analysis on how biochar works and when it does it, and that summarizes 14,000 papers, and that talks about the range of increase in soil carbon across those range of projects. And I think the other thing is about biochar and how it does work in a rumen. And so Sam, you talked about, why would you feed it as a feed supplement? And, if we have to keep doing it, then it's a problem. But unless your farm is balanced in all nutrients and minerals, then it's a substance that will always have benefit because of that redox active, but that electron, the high surface area has the surface area of a house, and it has this electron mediating substance, which means that when it's in a rumen, it will help the stimulation of the nutrients and minerals, and that they can be more highly absorbed by the animal. And then that same thing also occurs in the soil. And there's a number of nutritionists that comment on the need for an electron mediating substance in high energetic diets, especially in dairy. And one last thing that might help is how to get that biochar out to animals. So a lot of the research that's been done to date, it has been worked better with oils when it's fed, just a small amount of oil, because that helps with that redox active process in the rumen. And then, I've just found, rather than long big troughs, because I've got cattle myself, just putting it in smaller drums, if you like, with a little opening at the bottom. And it's almost like the thought of a lick. So they'll come and each animal will take its turn and come and have a lick. Just a few things, food for
Thanks
thought.
very much.
Leave it with you.
Thanks very much, Melissa. You're a wealth of knowledge. I won't comment any further. Now, we are past the hour. I know people's time is valuable. There are a lot of comments. There's 35 Q&A in the the questions to follow. I don't want to go too much longer. We could probably keep going for the next hour, and I appreciate people's time. There is a few other hands up, so I'm not sure whether Alex's hand is a residual. I'll let Steve and Joseph talk, and then we will wrap it up. I appreciate we haven't answered all the questions, but again, don't want to waffle on for too long. So I'll let Steve and Joseph talk. So hopefully you can unmute now, Stephen, and this will be the final comment.
Thanks very much, Matthew. Sorry, I missed the beginning. I got detained. Just to say that I think the thing that's changed since I got involved with both Doug Powell and then with this MLA CSIRO project is we're starting to understand what sort of biochars we need to develop that both help with weight gain and with methane reduction. It's taken them quite a long time to get none of us are animal scientists. And the animal scientists don't know too much about biochar. And I think the hard thing's been we've had very little money to actually do the fundamental studies. And I think, we've been carrying on doing that work with limited funds. But I think, I suspect we're going to see a breakthrough in the next 1 or 2 years. And how fast it actually happens depends on how much money we can get to make sure that what we develop is fit for purpose and really going to give some significant changes. The other thing I'd like to say is when you're looking at soil carbon, you need to do your trials over 3 years. Yeah, there's a lag time. And if you look at the work, say, that Lucas Van Zuyten's done or what I was involved in China, we don't seem to see a great deal of change for 3 years. And in fact, the work we did with Doug Powell in Western Australia, we actually looked at approximate changes in soil carbon, and we saw significant changes, but that was after 3 years. So none of these trials that you do under a year are really going to give you any accurate figure of what the potential is going to be.
Yeah, thanks, Stephen. And obviously, you've done a lot of research in biochar, and we appreciate your insights. The soil carbon stuff is difficult. Really, the farm experiments are difficult because you need to do a long-term field experiment to get robust and rigorous results. Although we really did it as partly for the biophysical, and a lot of the comments here today have been on the soil carbon, the live weight sort of stuff. But again, that was only part of it. We actually measured impact as well, longitudinal impact, and 5 or 6 farmers did adopt biochar after they had come to the workshop. So that was, they were seeing what Sam was doing, and then they adopted it 12 months later. Nikki followed up. The other part was Karen's scenario analysis, which was the cost benefit mitigation. And through that, we can sort of extrapolate, what sort of trajectories would you get with soil carbon over the long term if you applied different rates of biochar through feeding or directly to the soil. So that's all of those are fruitful areas for further research sort of thing. I know I keep saying it, but then scientists have to keep themselves in business with more research sort of thing. But there is a lot of scope for more research and very prospective particularly with the results that we had from the farmers in terms of the environmental side of things and animal health. So we do need to wrap up. We're 8 minutes over, and I appreciate I've only just touched the surface with the questions. Anyone has any further questions, just please get in touch with me. Again, thanks very much to the funding agencies, MLA and TIA, for funding the research, and thanks all for coming. Appreciate your time. We'll call it quits there, and thanks very much. See you later.
Yeah, thank you all.